just want to make a quick video because I left some feedback for some of you all, and towards the end of my grading, I realized that my feedback wasn't exactly accurate, and I want to make sure I correct that. So there's a problem we had on the lab where we were asked to sketch the angle 14 pi over 3. Typically speaking, when you're sketching your angle in radians and your denominator is odd, it's a good idea to ignore the y-axis. We know that we start at 0 and go to pi. I'm going to cut that top half into 3 pieces. Notice that the y-axis is not one of those cuts. We have 14 pi over 3, so we would have to continue cutting down into the bottom half. Notice that 3 pi over 3 is pi. Here would be 4 pi over 3, 5 pi over 3. A full revolution is 6 pi over 3, which is 2 pi. We can continue counting and counting and counting and counting. Another way to think of this is that 14 pi over 3 is the same thing as 12 pi over 3 plus 2 pi over 3. And I broke it down like that because 12 pi over 3 is 4 pi. I know 4 pi is 2 full revolutions. So if I'm sketching this angle, I would go to 2 pi over 3. I would go all the way around to 2 pi. I would go all the way around again to 4 pi. And then I would go an additional 2 pi over 3 landing there. And there is what my angle looks like. If you want to put the y-axis back in now, you could. But what's the purpose of this? Why am I making this video? Because what a lot of people sketched is they did not sketch this angle here. They instead just sketched this angle here. This is just 2 pi over 3. This does not go all the way around. It is not as big as 14 pi over 3. So you have to include these squiggly arrows to show that the angle is larger than a full revolution.